A very warm welcome to all. I am Chloé Rosset, Partnerships Engagement Lead at the UNEP Cool Coalition. It is a pleasure to open the first Cool Talk of 2026. Cool Talks is the UNEP Cool Coalition's monthly webinar series highlighting solutions, policies, and partnerships shaping the future of sustainable cooling. Today's session explores how innovation across the cooling ecosystem can generate evidence, tools, policy support, and enable implementation pathways to help move from solutions, from pilots to scale. Before we begin, a few notes. This session is being recorded and will be uploaded to the Cool Coalition YouTube channel today. All attendees are muted by default to ensure clear audio quality. Please submit your questions at any time through the Q&A box. We will take as many as time allows during the final segment and aim to respond to the remaining questions in writing. Innovation is central to achieving sustainable cooling at scale. Over recent years, programs like Tech Emerge have demonstrated that innovating cooling technologies can deliver strong performance across diverse contexts. What remains critical is connecting this innovation to enabling policies, investment-ready environments, and clear pathways for implementation so that solutions move beyond demonstration and reach markets and communities at scale. This is where the Global Cooling Pledge and the EPIC facility come in. The pledge is the world's first collective commitment to reducing cooling-related emissions by 68% by 2050, while achieving universal access to cooling. EPIC, short for Enabling Pledge Implementation for Cooling, provides Global Cooling Pledge signatories with targeted fast-track support to bridge policy, finance, and delivery gaps through two complementary components. EPIC Deploy focuses on pilot deployments of transformative, sustainable cooling technologies to generate real-world evidence and de-risk investment. EPIC Solutions provides technical assistance to national and subnational governments and support policy development, capacity building, and feasibility assessments across priority cooling areas. Together, these two pillars ensure that innovation informs policy, strengthens enabling environments, and supports market transformation at scale. On behalf of the UNEP Cool Coalition and all our partners, thank you again for being with us. I now have the pleasure to hand over to Rosemary Muzik, Global Cooling Lead at the International Finance Corporation and member of the Cool Coalition Steering Committee, to lead the chat on Tech Emerge findings. Rosemary, you have the floor.
Thank you so much, Chloe. It's always a pleasure to work with everybody here. I'm just going to actually put the report rather in the chat as I speak to you, and then we will turn over to the conversation. So we're structuring this as a bit of a Q&A process. But first, we have a welcome from our colleague Cho from the UK government, who's going to do a quick welcome and introduce the work that UK has been doing, and then myself and Selçuk Tanatar, who is the lead for the global cooling program through Tech Emerge, will have a Q&A chat around the report. Cho, turning over to you.
Thank you, Rasmir. So hello, everyone. I'm Cho. I'm from the UK government Department for Energy Security and Net Zero. Sustainable cooling is a cross-cutting development, climate, and resilience priority. And the UK is proud to help drive this agenda forward. Firstly, the UK is strongly committed to global leadership on cooling. Alongside the UNEP-led Cooling Coalition and the COP28 presidency, we are one of the originators and first signatories for the Global Cooling Pledge. And we continue to champion the dual ambition of reducing cooling-related emissions whilst expanding access to affordable cooling services. We play an active role in the coalition through leadership in the working groups and through representation from Graham Maidment on the executive committee. We are continuing to shape global cooperation and coordination. Secondly, we are embedding this agenda domestically. We are currently developing the UK Cooling Outlook, which is equivalent to the National Cooling Action Plan. In this, we will set out a comprehensive, evidence-based approach to meeting cooling needs at home, whilst ensuring our domestic policy supports and aligns with the international agenda. Thirdly, the UK is investing in innovation on a global scale. As part of the £1 billion commitment to the Ayrton Fund, we are supporting clean energy research. And as part of that, we are investing in the Tech Emerge and the Sustainable Cooling Fund. Separately, we have funded the Sustainable Cooling and Cold Chain Solutions Programme, which is being delivered by the UNEP and the University of Birmingham. And as a result, we have helped support the launch of the Africa Centre for Excellence for Sustainable Cooling and Cold Chain in Rwanda, along with outreach programmes in Kenya. These programmes provide a critical step in translating innovation into system-level impact by connecting innovators with local companies and supporting solutions to move beyond demonstration towards commercial viability. In this context, I'd like to highlight our strong partnership with the IFC. Their strong, on-the-ground delivery capability across healthcare, agriculture, and infrastructure is showing exactly where solutions need to be deployed to achieve real impact. Secondly, the Tech Emerge programme has shown to be an award-winning model for deploying innovation in emerging market contexts. And for this reason is why the UK has continued to support the Sustainable Cooling Fund. We believe this approach aligns strongly with the UK's innovation and climate focus. We are looking for ways to catalyse sector transformation, supporting the commercialisation of cooling solutions across a variety of sectors, from healthcare, from agriculture and infrastructure. We also want to back lighthouse demonstrations, identify projects that will have a transformative impact on both the sectors and regions in which they operate. We want to do this by driving research, development and innovation to ensure that cooling solutions become cleaner, more efficient and more affordable. And lastly, we want to do this by leveraging UK partnerships and expertise to help countries build investment-ready cooling and cold chain infrastructure aligned with national priorities. We are pleased to say that we are seeing the progress. Pilots are underway, innovators are being matched with real end users, and investors are taking a real interest in our credible pipeline of projects. This underscores the power of collaboration in moving promising ideas towards scalable market solutions. As we look ahead, I want to emphasize that collaboration will be essential. To the innovators, I would encourage you to continue using all the resources available to you out there, like the Tech Emerge database. To our delivery partners, IFC, I'd encourage you to continue sharing your lessons and evidence to make sure projects are replicable and scalable, and also continue our collaboration with our friends from the UN and the Ozone Secretariat. As I conclude, I'd like to thank the UN and the Cooling Coalition for leading and convening this critical discussion. I'd like to thank Graham for his continued engagement on the Executive Committee for the Cooling Coalition. I'd like to thank IFC for their leadership on Tech Emerge programme. And lastly, thank the innovators for whose work underpins all our progress. And with that, I'll hand over to Rasmir and Selçuk for a deeper dive into Tech Emerge findings. Thank you very much.
Thank you so much, Cho. I know that IFC certainly would not be able to do what we do without the generous support of the UK government and very much partnerships around the world. Let me now turn over to conversation with Selçuk, and this is a personal thank you to Selçuk because everything I know about cooling, I actually learned from him. So we'll go through, and hopefully you can see my screen, a bit of the results and lessons learned from the Tech Emerge program, which really was one of the first ways that the cooling innovation has started. So Selçuk, let's go through the challenges. We'll start with that slide. Why did IFC get into this idea of cooling, and what were the problems that we were trying to solve as the private sector arm of the World Bank Group?
Well, thank you, Rasmir, and again, thank you to UK government for supporting it. And we have listed the main issues that the whole world is mainly focused on, is that the cooling demand is rising globally, and it's essential for development. And And we are using and consuming a lot of energy. Actually, there are different estimates of somewhere between 17 to maybe 25% of the total energy is going for cooling, which is, of course, not acceptable for anyone, etc. But when we looked into it, it's like the funny thing, Rusmir, is when we started in 2019 and were in contact with the UK government, actually, we didn't want to do it initially, because when we talked to our investment colleagues, and as an investment bank, a finance, like a finance institution, there was no interest from the organization, because they said, no, cooling sector is not an investment target for us. It's dominated by 5, 6, maybe 7 large companies. They don't need our money, and so on. But then when we dug into it, then we realized something that nobody was really aware of, including me at that time, is that cooling is relevant and in some cases critical for almost all of our clients, whether you go from steel manufacturing to agriculture, etc. And it was incredible to see how much it was kind of, like in a blind spot of our investment companies and the companies that we invest in the emerging markets. Not only in the emerging markets, but also it's like, because the cooling is something everybody uses. It's like the refrigerator you have at home that just works, right? But it's not your primary business. So therefore, we said that this is really critically important, and even is like we were seeing that some of our clients, they were actually 30% of their OPEX were going for energy for cooling and so on. So therefore, we said, let's do something about it. And the second reason is that I work on the advisory part of where we are looking for development opportunities, collaborating with our investment colleagues. And what we were seeing is like there's a clear trend, and not a trend, but it's a fact actually, is that cooling is critical for economic development. Is when you look into the developed countries, they all have good, like cooling infrastructures, technologies, and etc. So it's not just on minimizing and reducing the waste, but it's also an enabler for economic development. And that's why we combine those two things. It's like critical for our investment in emerging markets and for the companies that we work with, plus that it has a huge amount of potential for economic development.
Let's talk about the innovation aspects, because that was one of the things that you highlighted, Selçuk, because you said this work is being dominated by big companies. They are incrementally evolving. There hasn't really been a leapfrog in the way that, let's say, EVs or other technologies have done. So what is actually stopping innovation from really going forward, and what are some of the failures in that work?
Yeah. So the innovation part is, like that's also one of the things that we spent almost 6 months doing a kind of a landscape study of where innovation and new cooling technologies stand. And one thing that we realized that, again, it's a blind spot for almost all sectors. So therefore, it is just something that everybody is using. And that innovation and progress in making cooling more efficient had actually stalled. Actually, according to IIA numbers, we saw that it was only about 1.5% per year since 1990 that the cooling efficiency had been improving. And according to the theoretical efficiency, it's like we are at around 20%, 25% today, whereas for 100 years ago, it was around 10, 12%. Then when we compare to other technologies, like, for example, LED lamps that we all use, it's like that moved from 10% to almost 90% over the last 30, 40 years. So therefore, it's like we were saying that there is a need for innovation. But when you go to the slide on, like on technologies and why innovation, what is lacking is like the weak innovator capacity and adopter capacity. When we mean the weak innovator capacity, we saw that many of our innovators, they were focusing mainly on one aspect of a cooling system, one chain, because the cooling systems is a combination of multiple technologies. And most of the innovators were focusing on one specific part. And then on the other side, as I mentioned, on the weak adopter capacity, is that again, because that it is like the refrigerator, I didn't even know when we started the program how a refrigerator works. So I had to go into it. So it's not my business of doing cooling. Like cooling is just an enabler, and you just accept it as something that you just pay for as you consume it, and you just realize the importance of cooling when it breaks down. You don't really think about the efficiency. So that is when we were looking into the adopters and etc. We saw that many of them, actually, most of them, didn't even know how the system worked. So combining those two things, when we looked in, is like that the innovator, they were assuming that the user of the adopter, or the adopters as we call them, that they know how the system works, and they plug in a specific device and that it would work. So those are kind of the two challenges that we were facing. And then the second part is that because cooling is, again, something which is in the blind spot, that designing a pilot for doing and testing a technology, it was very challenging for most of them, which then led to, in many cases, to mission creep. They started with one area, and then they realized, oh, it's also relevant and related to other aspects of the cooling systems and so on. So there was a kind of a mission creep coming in, which in some cases ended to that we didn't really get a good overview on whether the technology worked or not. But fortunately, we had a series of experts who were working with our innovators and adopters, educating them and helping them on setting up proper pilots and making sure that we could have, factual information, as I'm calling it, on what is achievable and whether it works or doesn't work and what needs to be improved.
That's great. And Selçuk, let's then now turn to, a lot of great results from the in the report, and give us the highlight of the main findings of what the experience was from Tech Emerge, and then we'll kind of deep dive into technologies and your lessons learned and recommendations for the future. So, what were the main kind of big takeaways from the report?
Yeah. So it was all 4 years, right? It was quite a journey. It was a very exciting journey for all of us. And we engaged with more than 40 innovators, 50 plus different unique technologies. And then we had like very large corporates, like, for example, IHCL, or better known as Taj Hotels in India, with 200 and almost 300 hotels across the globe. And they was claiming that their OPEX is like 30 to 50% of the OPEX actually went into cooling. But we also had we went into Africa and looked really into the, like ground level, small technologies and etc., and implemented about 100 pilots of the different technologies. So the kind of different things is like one of the things that we can maybe also go into some of the results in terms of numbers and etc. later on. But it is like we have seen that achieving better efficiency is definitely possible. And you start at minimum 15 with basic things like better management of your existing system without embedding any technology, but maybe using a technology as an enabler already gives you 10, 15% or so. And then when you start to be more, like go into the details, technical possibilities, and start to add on the different technologies together, in some cases we have seen that reduction up to like 80%, 90% of the cost for cooling. The other thing is like we have also seen that there's a huge need for de-risking technologies, because again, as I was saying, because cooling is something we just use and don't think about how it works, there is also a lot of conservatism around adopters. It's like there is a kind of a tendency, don't fix it if it works, right? So we don't want to do something if it works. We don't really think about whether it's efficient and etc. We just want anybody to like go in and try to do something else while it's working, because the existing systems, they work, but they don't work efficiently. So that coming over that threshold is like the pilots and the structured way and the way that we were working with our adopters primarily and explaining them and managing the risks of adopting and testing a new technology, that has been extremely valuable. And we have received a lot of compliments from the companies that we have worked with. On the other side, with innovators, it's also like they are facing this challenge again when they go to clients and say, "Hey, I have a new technology," and they meet, like face a tendency of "don't fix it while it works." They have quite a difficulty in doing field tests and trying to see how their technology works and performs and etc. in the field. So this way of supporting the piloting, etc., has created a tremendous change, both in the mindset of the adopters, because they have seen and they realized that the risk of testing a new technology can actually be managed, while for our innovators, the biggest gain probably has been for them to see, hey, there's something that we have overseen or we have not really thought about, because they have not, once they go into the field and as we say, like when the rubber hits the road, then you don't really know what can go wrong, etc. So that has created a lot of information and data and insight into cooling systems. So I could probably go on like for a day or so on all the lessons learned and etc. But please look into our report. We are like also highlighting a lot of case studies in terms of where we are, like on all the things that were very exciting that even we didn't really foresee that popped up.
What happened? No, that's great. And I'm monitoring the questions as well. So the first one is, the report is already live. You may have missed it in the run-up of the chat. I put the link, but I will repost it once Selçuk and I are finished. But Selçuk, let's turn to specific specific technologies. So Balaji had one of the questions. Did TechEmerge look at cross-cooling applications or related to specific ones, for example, residential ACs, commercial ACs, or others? And then this is one of the tables that is available in the report. So again, lots of information here, lots of data. And my question to you would be, what is the technology that you were kind of most excited about given the pilot testing? What showed the most promise? And whatnot. So we can answer Balaji's question on who did TechEmerge work with, and then if you can use this table to kind of highlight to us where you think the most promising technologies are.
Yeah. So the measurement and the data that we have, is I think it's probably the first time that someone has been doing this comprehensive of research and like an implementation and trying to collect data. And one of the things that we have seen in the data side is like when we were talking to innovators and providers of technologies, they came up with claims about what they could achieve, but it had never been field tested, or it had never been like verified by a third party and so on. So that's where this data for us was so interesting. So there's a lot of data and a lot of things that we can dive, but I'll just try to maybe look into like three main things, like most successful. I think the most successful technologies, individual technologies, probably the phase change material. There was a huge interest and also a lot of pilots, and we had like 29 pilots, almost 1/3 of our pilots involved the phase change materials, right? Where we saw that you can easily achieve something like somewhere minimum of, I would probably say in average, like 35-40% by embedding phase change material for cold storage facilities, for transport, for any side. So it's like kind of a phase change material for colleagues who maybe don't know. It's just a heat battery, right? It's like you don't reserve your energy as an electricity, but you store it as heat in different temperatures and so on. So that's probably it. But I think one thing that also on the most promising is what we saw a big difference is when you start to combine multiple technologies. So that's where I think is probably the most important, when you try to get renewable energy integration, the phase change material, and controls and optimization, etc., which of course makes pilots and projects more complex. But we have seen that, like with impressive figures like 80-90%, and in some case, they were claiming that they were going totally off-grid with the technology. So those are probably two things. Then maybe on the most, or how to say, lowest cost or bang for the buck category is maybe, like coating and treatments, like surface treatment of different applications, whether it be walls or roofs or of a different material for rejection of or solar heat and etc. Is like those are probably the most lowest cost together with the controls and optimization. Then I can tell you, like, from 20, 30 years ago when the IoT devices and etc. and AI were not used, from there to today is like just implementing these very quite low cost technologies into your cooling systems without changing anything on the cool production or usage of it and etc. That can minimum give you like 15-20% if you start to use those technologies. So those are the kind of the technologies that I think. And then other things that I will maybe also address is like on how we use cooling, and that's mainly in the air handling and the quality of the air as we are saying it. Just also starting focusing on technologies to make the air more better and also handling the air better is also relatively low cost, but gives a big bang for the buck in terms of what we achieve. Lastly, most promising technologies, and there we have, and these are like early technologies, like it's like those that have the highest potential that can target like 40, 50, 60, up to 70, 80%. And in some cases, they can totally eliminate electricity consumption. The technologies like add or absorption technologies, vacuum cooling, and better heat energy exchangers and etc. that we have seen some of. Unfortunately, these technologies are at this stage, they are at a very early stage in their technology readiness level. So therefore, you may have seen that there are some inconclusive results where we have seen promising results, but we would not be including it in the report because they were inconclusive and need a longer time for testing and a further road for improvement and further work. So those are the things that I would definitely, if I were going to bet my money on investment, I would definitely go in and look into the companies that are working with new materials and for heat exchange and so on.
Awesome. Lots of great more comments coming through. But Seljuk, let's turn over to kind of your lessons learned from this, and then I'll have you end with the kind of your recommendations, really how to then move this forward.
Yeah. So again, like as I said, when we were writing the report, we were targeting to have a 20 or 25 pages. But as we were writing it, there were so many details and lessons learned. So the report has actually become quite long. So there are a lot of, but I would maybe focus on three main things of the things that we are showing here, right? Is that one key lesson learned is that we realized on how we use cooling, how we produce cooling, how we store and how we transform cooling. That needs some kind of a transformation. We have seen that many people, they just accept it, as I said, like when you go into, for example, a hotel or you go work with the agri companies, there are some industry standards for what cooling needs to be, and people just follow them literally in how it is defined. But then when you talk with experts who are, for example, producing and selling agri products, or are looking into how, like on the comfort side, are dealing with, are you a guest in a hotel or in a commercial building, in an office building, do they feel okay? It's like then we have seen that there is a big gap in terms of how we use cooling, in terms of what we are producing and how we are transforming that cooling side. So therefore, it's like we have seen, for example, one quick example is an ice cream transporter manufacturer. They were going with way cooler transport specifications than what they needed, but they had put in safeguards in terms of, like when the equipment goes down, we will have maybe 1 or 2 more hours. Without really thinking about new technology, you actually don't. So you can take that. So the safeguards are off and save a lot from that side. So the transformation, how are we using cooling? That's one thing. And then for innovators, of course, that relates to the innovators that probably 70, 80% of the technology we have seen are incremental improvement of existing technologies, right? 100 years old technologies, 50-year-old technologies. Phase change materials, for example, have been known for more than 40, 50 years or maybe more. And therefore, we have to have better incubation and better support for innovators to go for the really, like the things that will change how we produce the cooling. And again, as I said, for example, the vacuum cooling, new materials in terms of coating and etc. that improves the heat transfer is very important. So those two things have to be a kind of looked into on how do we use it and how do we produce it and then innovate in that path. The second thing is maybe like a key critical where tech emerge and your work, IFC's work in the cooling is demonstration of that the cooling technologies work, and they work, and people should not be like afraid of it. But there is a kind of a mentality that we have to overcome in terms of and try to break that. Don't fix it, like if it works mentality, and that's where the demonstration it really meets it becomes important. And then maybe as a last thing and part of the transformation is that we also have to try to think about the affordability needs of the cooling customers and then also the specialization, and maybe think about setting up some kind of a new systems where it becomes somebody's work to be the cooling expert. Because as I tell you, it's like in many factories and the companies that we invest in, cooling is not the primary business. So therefore, we are, for example, suggesting that cooling as a service models, business models, together with a new blended financing model, is going to be critical for the continuous improvement of the cooling systems.
That's great. And I think that kind of leads into some of the recommendations. So any one key takeaway and recommendations for the partnerships that Joe mentioned and others where you think we should go in.
Yeah, as I said, the leapfrog technologies, right? That is one thing that I think is going to be key thing. I don't think with the incremental improvement in cooling technology, we have a kind of reached what is possible or is about to reach what is possible with existing technologies, with existing compressors, with existing, like heat exchangers and so on. So there are a lot of things that I know that is happening at the laboratory level, and in some universities and etc. are working, for example, on metal organic frameworks and better, like technologies for compressors and so on. And therefore, I think that's one of the things that I think definitely that we should be focusing a lot more on. But it is, again, at the lower technology readiness levels. And then I think one thing which is probably going to be critical is the considering cooling blind spots and adopts a needs-driven approach is, or maybe I'll start with the news, which I've already touched, is like look into and work for innovators specifically, right? Work with your clients, try to understand what their needs are and how they do it at the moment, and then identify opportunities for how it can be done better. It does require a lot of work, and innovators should go in and looking at cooling systems, not just focusing on that specific technology that they're working with, because the technology will need to be integrated with many other systems, getting from water and so on. On the blind spots, it's like this is one very interesting area, right? It's like so that we learned, including ourselves, that we were not, is that there are a lot of areas that are not in the spot, in the focus, and we don't know much about. And for example, like for agribusiness, because of the like the climate change, increase in temperatures, we have already got reports from many of our agribusiness clients that their yields are going down because the different plants do not get the sufficient chill hours that they need in order to regerminate and so on. Animal produce, for example, is like, cows and etc. is like they need a certain amount of cooling in order to be productive. Their productivity, for example, with the cows and milk in dairy, it goes down. So we are spending money on cooling cows, actually. A lot of companies are doing it already, but it is an extra cost for them. And then the thing that I'm actually mostly concerned about is the academic achievement, right? We know in the poorer countries that where you can't afford cooling, we have also seen signs of that the academic achievement is also going to be worse, or it's going to be less than when you have cooling. And we have done some very interesting work with the two universities in Mexico that are actually showing results of some of these things. So, the reason to that it worries me a lot is that in order to get economic development in the emerging markets, you need skilled people, you need good engineers, and etc. But when you cannot have skilled people and educate good people in your country, you're kind of going to be bound not to be able to develop your country as well as before, as others. And then, of course, the most important, and kudos to our colleagues in IFC, who is running the Edge Green Building Program, is passive cooling systems. I think that's probably one of the areas that you should be starting with first before investing or looking into new technology and looking into seeing what can I do with my building and what can I do with my equipment to reduce the need for cooling, because that will also reduce the need for energy. But we are going to need more cooling, independent of that, but start there first and then, then work out the technologies.
Great. Thank you so much, Selçuk. There's great questions coming. We will address them in just a bit. But one of the ones that came through was how new innovators can join us, and that's really the part of my piece. So I'm going to skip a few things here of how IFC can support you. I think we have talked about this in previous webinars, and you'll get this packet. But I'm really going to turn to what we are now doing with the Tech Emerge initiative. So again, continuing with the support of the UK government, we are now able to do another open call for initiatives, and we're using the Tech Emerge website. So there are 3 open calls you'll see for cold chains, cooling for agribusiness value chains, and global space cooling. We actually just made a relationship with ILO and their Better Works program. So we're going to look into some sensors for textiles and what work looks there. So these will be ongoing initiatives where we are encouraging people to apply. The Tech Emerge database is also now a public good. So we're allowing access to the database of these innovators to everybody. You'll be able to do that from techemerge.org. I'll give you a quick screenshot here on what this part looks like. And our Liana, who I think is on the call with us, they're doing some more enhancements to the database to make it very easy for you to sort, to see where you can find people in your area of operation. This is kind of like, again, a good screenshot of a deep dive of what this information looks like that we already have. So this is the info on Plus, one of the companies that we worked in out of India, but they have done a lot of pilots all across Africa, including Nigeria, where Cho and I will be next week. And you'll actually, for the pilots that we have, you'll be able to see the linkages. So you'll see, and we're going to now populate the case studies of these pilots given the results of the Tech Emerge report, so that all of this information is available to you on the website. We are encouraging new innovators to apply. So again, if you joined us as an innovator and new to this work, this is a very quick screenshot of how you can join the Tech Emerge database and sign up as an innovator. We do think that this is kind of like the premier place where you can find all of the great innovators across the world, but the work isn't done. Tech Emerge has been wrapping up their work, and so we are encouraging new innovators to apply and to submit their work into the open calls. So I mentioned we'll be in Nigeria next week with Cho. I go from there to Egypt. So we're continuing the work, working with UNEP, Cool Coalition, to operationalize the Global Cooling Pledge and make sure that there's lots of awareness and partnerships across the board for this work. So I'll stop here. We may be a little bit over time, but I think we were answering some of the questions along the way. So I'll turn it back to you all for next steps. Chloe, back to you.
Thank you very much, Rusmir, for those insights and for guiding us through the lessons from Tech Emerge. So we will now turn to the next part of our program, which looks at how evidence from cooling innovation can inform practical policy tools for sustainable cooling. I am pleased to give the floor to Stephanie Eger-Highsmith, Communications and Information Officer at the Ozone Secretariat, who will present the Online Policy Toolkit for Sustainable Cooling. Stephanie, over to you. Thank you.
Thank you very much, Chloe. Can everybody hear me? I'm just waiting for the presentation to come up. There it is. Thank you very much. And in the interest of time, we'll get stuck straight away. As just introduced by Chloe, I am going to go through the new Online Policy Toolkit. But before I do that, I just want to run you through why access to information that guides and provides actionable policy options for policymakers to promote sustainability in the cooling sector, why that's so important. And I think it's specifically with respect to implementing the Kigali Amendment and supporting national action with respect to sustainable cooling. So to date, 172 out of the 198 parties have ratified the amendment. That's well over 3/4, but that still leaves 26 to ratify. And obviously at the Secretariat, we would like to see universal ratification of this amendment, this key cooling tool this year, because we're celebrating the 10th anniversary and we want full ratification to reap the full benefits of this cooling tool. So obviously a quick recap. I think most of you know what the Kigali Amendment is all about. It's all about phasing down hydrofluorocarbons, or HFCs. There are two different phase down schedules. The developed countries, or our Article 2 parties, already started their reductions in 2019. And developing countries, or Article 5 parties, Group 1, started their freeze and consumption 2 years ago, so 2024, and Group 2 will commence that in 2028. So the final phase down in terms of reduction steps will therefore occur between 2045 and 2047 for Article 5 parties. By linking a country's mandatory HFC reduction obligations, so these are the ratifiers, the amendment promotes the use of more sustainable refrigerants in tandem with the adoption of more energy efficient cooling technology. And this is where this toolkit really comes into its own, and we do hope that this provides the support that it's intended to do. So next slide, please. So to support countries in their sustainable cooling efforts, the Montreal Protocol Ozone Secretariat has built a pretty comprehensive policy toolkit that I think guides and helps provide actionable policy options for promoting sustainability in this very important sector. Hosted on the new coalition's Cool Coalition's website. It's also accessible directly from our website from the Ozone Secretariat. So the toolkit assists policymakers and implementing agencies in developing and operationalizing effective policy frameworks that hopefully encourage the transition to more sustainable refrigeration, air conditioning, and heat pump systems. It is also designed to provide guidance on improving sustainability in the sector, contributing to broader climate goals and economic benefits, as well as help promote the supply and adoption of energy efficient technologies, equipment, and practices in the RAC and HP sector. The toolkit maps possible policy measures along the cooling sector value chain to help users manage and phase down high GWP refrigerants, enhance energy efficiency of cooling equipment, improve energy efficiency of building envelopes to reduce cooling loads, and also implement passive cooling solutions to reduce the need for mechanical cooling. Next slide, please. So various policy instruments can be considered in developing and implementing a balanced and comprehensive strategy for an optimal and rapid transition of the cooling sector. And to enable such a vision, policy options in this toolkit are mapped across the value chain of the cooling sector. And I think if all goes well, we can have a quick demo. So hopefully you will be able to see the toolkit. Yes, fantastic. So there are 4 key areas for the user to consider that include energy efficiency of cooling equipment that showcases effective interventions to boost cooling efficiencies, passive cooling solutions for inclusion. That's it. Yeah, in building design and urban planning that use nature-based passive cooling solutions rather than mechanical. And then you've got the refrigerant management and phase down of climate warming HFCs to help manage the reduction use of high GWT refrigerants. And then, as I mentioned before, the other cross-cutting policies in support of improving cooling efficiencies, such as LRM. So overall, all 4 sections include a variety of instruments. We can look at one of them. Let's look at energy efficiency. There, yeah. So if you click on energy efficiency, after a brief overview of the section, further down, you'll find a list of sort of key policy interventions that can be accessed, from building energy codes to minimum energy performance standards. And if we click on MEPS, for example, let me go back. Yeah. There's another brief overview of the benefits of establishing MEPS for cooling appliances. And then you also have a click option to view various resources. There you go. For example, United for Efficiency, U4E. And we have a number of different resources from different organizations to get a much sort of, or a broad and comprehensive overview as possible of what some of what the options are. Similarly, if you go back up to energy labeling and consumer awareness, you can see a sort of a similar format with access to examples. And again, here you've got U4E. And if you actually click further along onto 2 and 3, you can see that, CLASP is also in there, as well as the International Energy Agency. Brilliant. Thank you. So the various tools are also classified. Actually, if you could just stop there or go back down again, are also classified where a user can search by type of policy. Yeah, there you can see. So type of policy, so that could be regulatory, financial incentives. There you go, public-private partnerships, or target groups, which can include government, policymakers, and the business sector. The value chain for search options on electricity generation, refrigeration production, retail, and then resource types that the user can then specify in its search, such as guidelines, regulations, or case studies, whatever their sort of, preferences in terms of the format of the information that they're looking for. You can also search within the Policy Toolkit resource that can be narrowed down to specific countries or regions if you specifically want information based or generated out of there, because that's then sort of, industry specific to you. Okay, I think in the interest of time, I'll stop here. But yeah, I think it's safe to say it's a really comprehensive resource. And I encourage anyone to go and look at it, which we will also continuously build on as new technologies, guidelines, and other relevant information become available. Thank you very much. And thank you, Marie-Sophie.
Thank you very much, Stephanie, for walking us through the Online Policy Toolkit. We will now move to the panel discussion and Q&A portion of the webinar. So for this session, Rosmir will be moderating the discussion. Rosmir, I'll hand it back to you.
Excellent. No, the questions are coming, and we encourage you all to please, submit them along the way. One of the questions I think Selçuk and I can take, which came earlier, which is about SWAC, which is the seawater air conditioning. And the question was, what happened with those pilots? So seawater cooling is quite intensive. So this is one technology where it's not easy to do just a pilot. There's a lot of work that needs to get done into pre-feasibility studies, feasibility studies, and others. We do have another report by IFC. It's called the Cooler Finance Report, where we went through a number of different promising technologies, and the seawater cooling is included there. So this is where IFC is partnering with our colleagues from the World Bank, because some of these larger infrastructure initiatives do need public policy to really enable it. And our colleague Jonathan Cooney is working on seawater cooling. He thinks that the work in the Caribbean is the most promising. Let's see. One of the questions came for Stephanie, which is for Latin America and the toolkit. So if Latin America is included in the toolkit, and if not, why not?
That's a very good question, and I can assure you it most certainly is included. Perhaps it wasn't visible on the drop-down, but we have Africa, Asia Pacific, Europe, Global, and Latin America, and the Caribbean. So yes, it is there. It is included.
Excellent. And from IFC side, we actually, as Selçuk mentioned, one of our really recommendations, and this came from both UNEP and IFC, is to really utilize the passive cooling technologies. And so we actually have a policy toolkit it's written in Spanish, and it was the result of our knowledge and learning working with cities, mostly on the municipal side, on creating public policy incentives, many of which are non-fiscal nature. So, allowing extra floors or expediting permitting can be something that's really valuable to developers. It does not cost the government anything, but it is valuable, and it creates a more sustainable world where, again, energy efficiency in a lot of the hot countries where we work with is really cooling energy efficiency. That's where it comes from. Let me send a question to Cho, and then to Selçuk, which is really about the collaboration. So you talked about the instances and the need for partnerships. What are some of the public-private collaborations that you see as being most effective, or that you would encourage the people working on this to do?
Thank you for that question. I think the most important thing in terms of public-private collaboration is essentially working out who are the kind of the key players in the space. We have a lot of development institutions, for example, British International Investment, who is interested in co-financing the projects that we have in our database, in Tech Emerge and beyond. And we think also academics are really important and crucial in terms of driving that collaboration. So I think there's key players across the landscape that can really be beneficial to moving these solutions to scale. And we just really want to continue seeing that collaboration going forward.
Selçuk, any comments from you on the collaboration elements?
Definitely, yes. I think the public, and private, is definitely one of the, again, lessons learned. But there's a lot of need, not just only opportunities, but there's a need for collaboration primarily between the academia and innovators, because that's one of the areas that we have seen that innovators, they don't have the sufficient, testing possibilities, or they don't have the sufficient academic knowledge in terms of, for example, when you work with the cooling, you go both into mechanical engineering, electrical engineering, and etc. And those are the kind of the things that we definitely encourage all our innovators to establish close collaboration with academia in different countries. The second part is on testing facilities, and that's again one of the areas that we have seen both also on the program that was run, for example, on the I think it was the 5X program in India, is in terms of measurement and testing. facilities, which again is like collaboration with the academia is a must in order to be doing proper measurement, testing, and validation of the technologies that we work with. And then maybe again, the last thing, again, very important to the academia collaboration is on as I said, if you're going to have the leapfrog technologies, it will go through the science, very thorough and robust scientific research that will then be adopted by the innovators and commercialized. So those are the areas. And lastly, also we have been in discussion with like on other actors in the field on the public side, on the support for innovators, but also academia. So both with policy for innovation, but also policies that will promote better technologies and better efficiencies in our living environment and all the areas that we are working on.
Excellent. I think that's maybe my personal ask to colleagues in UNEP and even our donors from the UK government is to help set up additional testing centers like ACES was done in Africa.
We had a very successful project in India where we worked with the Indian Institute of Technology in Jammu, the IIT Jammu, where we helped them as a pilot to see how can we support this kind of where they actually set up laboratories and facilities for innovators in India that they could test with, and which is supported by large corporates like, for example, IHCL, the Taj Hotels, and by Tabreed. They're all looking for new innovations in this area.
Excellent. I think we may have time, maybe one or two questions. One more subject to you. I think this is a really good one. Are any of the pilots in the Tech Emerge on path to commercialization? What does the demand look like? What is the role of local manufacturers? So from your experience, who now is in fact scaling up?
Oh yeah, we have, I think, probably the most successful is EcoZen that we worked with in India. And when we worked with them, they were only operating, I think, in one or two markets, primarily India and maybe another market in Asia. With our support, they went into Africa, and now they are scaling up. And I think they raised close to maybe 60 million since we started working with them and are continuing expanding into other regions and etc. Plus Technologies, again, from India is another one. Coolbox in Nigeria is, I think somebody mentioned that they also featured in a report, in other reports is on how they have. So yes, they're definitely moving on and are commercializing some of the, but again, field testing, learning, improving the technology. Those are the companies that have really benefited, the companies that I mentioned that benefited and that manage that process very well. There are also other technologies, innovators that are not that yet there, but we are confident that they will be coming into, like on the commercialization stage yet. But they are mostly the companies that are working on these groundbreaking technologies, as we are saying, on and absorption and new materials, vacuum cooling, and so on.
Excellent. I can see on the chat, our colleagues from Coolbox are also joining and talking about their work. Stephanie, let me send maybe the last question to you, and I will confess, I think IFC has worked a little bit closer on the efficiency side, and Ozone Secretariat is working more on the GWP, which stands for the low global warming potential refrigerants. So there's a question from Maria on how to analyze the effects of low GWP refrigerants on the energy efficiency of the equipment. Is there a general relation, or does it depend on the case? So what are some of the work that you're doing from the Ozone Secretariat to really establish that link on, changing the coolants to the business case on the energy efficiency?
Well, I think that side of the information obviously comes out from the TEEP are technical and economic assessment panels. So they are the ones that are sort of, analyzing this sort of information based on studies and research that they can find in the sector. So the best place actually to get that sort of information would actually be towards the end of this year, when all of our assessment panels produce their next quadrennial assessment report. So the TEEP, the Technology and Economic Assessment Panel will be looking at all of that information very closely, and that's where you will get, that's where you'll be able to see sort of, you know, what are the impacts of all of those interventions.
Excellent. So stay tuned for more analysis and more reports. Chloe, let me turn it over to you to wrap us. We're right at time. There are a couple of more questions and comments. We'll see if we can answer them later on. And reminder to everybody, you know, be on the lookout. We have recorded this and we'll post the summary and the video as well as all of the materials that were presented.
Thank you, Rosmir. Thank you to all our speakers and participants for a rich and engaging discussion and the many questions that we've had. Today's conversation really highlighted how innovation combined with effective policies, practical tools, and clear implementation pathways can really drive sustainable cooling at scale, as illustrated by the initiatives we mentioned, such as Tech Emerge, the EPIC facility, and the Online Policy Toolkit for Sustainable Cooling. We encourage all participants to explore how those resources can be further considered and how they can be applied within their own national and or local contexts. A summary article of this session will be published on the UNEP Cool Coalition website in the coming days. Thank you again for joining this Cool Talk and for your continued engagement in advancing sustainable cooling. We look forward to welcoming you to our next session. Thank you, everyone.